Dear friends, in this lecture 14, we are now going to summarize the studies what we conducted in the first module, which focused on safety assurance and assessment in the course of health, safety and environmental management in offshore and petroleum engineering under the NPTEL Braces IIT Madras. The first module of the course focused on safety assurance and assessment. We will talk about summary and highlights of this particular module for closing this module 1 lectures at NPTEL. Let us quickly see what are the topics we covered in the first module. We spoke about introduction to safety, we discussed safety assurance, safety in design and operations, we focused on organizing for safety, we discussed problems associated to hazard identification, classification, assessment and evaluation. We also discussed case study on hazard reports. We also understood how to conduct failure mode effect analysis for 2 example problems. Dear friends, oil and gas industry makes continuous technological progress, and this growth, as we all understand, is highly rapid. Complexities at various stages like exploration stage, transportation stage, processing stage are entirely different. They lead to constant change in manpower requirements and skill levels. Most important is to improve the conditions of work, therefore ensure safety, which becomes most important in the operational plant. Physical hazards and new unperfected technologies are being attempted in different segments in the world to counteract the complexities involved in deep water oil exploration. This of course leads to fear of compromise in safety. Let us follow simple rules of safety assurance, which has been discussed in the previous lectures on module 1. Let us try to minimize and control hazardous incidents. Examples of different procedures followed in different countries like United States, UK and Europe. They have jointly developed different effective process safety programs, and of course they proposed better and stringent regulations that need to be adopted by this industry. Overall, the idea is to minimize and control the hazardous incidents which had occurred in the recent past. It is also important for us to know, friends, that one should perform HSC audit to understand the effectiveness of HSC management. HSC management need to be retrospectively audited by a third party to see how efficiently this is being practiced in a specific industry, and this is a mandate as far as oil and gas industries are concerned under the present regulations. We also have studied about International Sustainability Rating System, which is called as ISRS. It is an international practice to measure the effectiveness of HSC management of any company. We have also seen what are the different segments which are participating in the ISRS program, and we have understood how globally ISRS can be conducted to ensure or to measure effectiveness of HSC management in any process industry, nevertheless as applied to oil and gas industries also. We have also discussed couple of interesting case studies. From the case studies we inferred that 75% of these are essentially due to human and organizational factors. The remaining 25% arise from the flaws in engineering design and selection of equipments. We have also seen in the recent past various developments and technology advancements made in the design updates have started declining the accident possibilities that arise from the faulty design. Therefore, if at all any accident as on today is foreseen or envisaged, you can always believe that is going to be human machine interface or organizational factors which will become responsible to foresee such kind of accidents in oil and gas industries. So, under the given task, it becomes very important for us to understand that safety training is very vital for all the personnel involved in oil and gas industries. We have also seen in the lectures that how safety and risk can be compared. We have understood that safety and risk are contemporary. Safety is a highly subjective term. It cannot be measured. It varies qualitatively from one personnel to the other or one's perspective with respect to the other. However, risk can easily be quantified. Hence, quantitative risk assessment methods, which we call abbreviatedly as QRA, was very popular in HSE management. We have also seen that there are three systems which are commonly used to measure the accidents in offshore industry. OSHA, which is known as Occupational Safety and Health Administration by United States Department of Labor, prescribes a method to measure accidents in offshore industry. You can also measure accidents by a technique called fatality accident rate, which is called FAR, or alternatively you can measure accidents by fatality rate per person per year in the company. Let us try to understand that safety and risk becoming contemporary. We cannot measure safety because being a subjective tool, so we measure risk and try to identify safety indirectly through risk assessment and management. Once this is said and understood, now we went along and tried to find out that risk is now a combination of possible consequences and associated uncertainties. There can be different assessments of uncertainties. There can be different views how to deal with these uncertainties. Risk estimates are therefore, friends, a decision making process. To activate any decision making process, goals are to be set. Therefore, we have got two distinct set of goals available in risk management in oil and gas industries, which we discussed in the previous lectures. Goals of risk assessment are therefore aiming at risk reduction and risk elimination. Dear friends, we have clearly understood that risk is a three-dimensional problem. The first dimension comes from the probability of occurrence of any event. The second dimension is associated with the consequences if the event occurs, and of course the third dimension is manageability of the event if it occurs. So, the third one is clearly called risk management. The first and second one are called risk assessment. Risk, of course, is acceptable to regulatory agency and also to the public, which is predefined in the literature. Dear friends, please understand, offshore and oil and gas industry is not an industry where zero risk is involved. The process is of a very high complex in nature. Therefore, under operational temperature and pressure, there is always a probability that accidents do occur. If accidents are available or they are going to be caused because of unforeseen incidents, then you can always say risk cannot become zero in oil and gas industries. Therefore, different regulatory agencies in the world have designated what is called acceptable level of risk, which is acceptable to the company, to the personnel, and also in form of societal risk to the public. Risk assessment unfortunately relies on inadequate scientific information or lack of data, because the accidents are declining in the recent past, which is a good news. But however, learning lessons from accidents are not happening frequently, because the data available based on which risk assessments are made or rehearsed are very few, and we call them as inadequate scientific information. If this is understood clearly, then we also have to understand and realize that there are certain limitations in safety assurance program. The aging assets, the platforms becoming older, the material degradation, the strength degradation because of various combination of environmental factors make them aged, and that is one of the main worry which limits the safety assurance in offshore platforms. The second major cause or the limitation is return on investment in safety. Practically, if you look at the financial perspective of investment on safety, the return on this is phenomenally low, or one can even say it is practically next to 0. Installations located in thickly populated areas cause lot of worries. Non-adherence to standard operating procedures, because many of them are attempting new technologies and complex machineries which are involved in oil and gas production and processing. The top down safety culture is one which is highly missing, which is now improving, that is a good news. However, this was found missing in many of the leading oil and gas industries. As we all understand, as there is a constant update in technological processes, we foresee a very acute shortage of skilled manpower to operate these process plants. Of course, there is lack of proper maintenance which is scheduled, which must have been done in these kind of industries, and most importantly training and retraining of manpower to assimilate the upcoming technology is a big black hole in many of the oil and gas industries. Dear friends, please realize safety is not expensive, it is priceless. The moment we have safety in our mind, then we can quickly compare two interesting domains of safety. One is the process safety, other is the personal safety. Process safety is actually addressing the hazards which are initiated from major accidents. They result in release of chemicals, cause fire, explosion, etc. These incidents or accidents are essentially high consequence, low frequency phenomena. On the other hand, if you look at personal safety, it gives rise to incidents such as injuries, fatalities, etc. A few examples of this order which is commonly seen in oil and gas industries are the falls, trips, crushing, electrocution, etc. If you look at the whole phenomena in general and compare it with process safety, one can realize that personal safety phenomena or accidents and incidents are low consequence, high frequency. As we all now realize, risk is a product of these two. However, risk in terms of process management and personnel management, both are important. Therefore, HSE covers both by and large. Then one can ask a question, how can we improvise safety in drilling operation, which is one of the major source of many accidents that has happened in the recent past. We discussed in one of the lectures that system design concept can certainly improve safety in drilling operations. The best way to minimize injuries, illness and fatalities is to design the plant with minimum hazards and risk. Though the statement is highly conceptual, but still this can be implemented with lot of engineering methodologies in the design stage itself. By designing properly, one can certainly eliminate hazards and control risk to a very greater extent, can bring the risk to an acceptable level even at the source itself. Controlling risk is a good idea, it is a good habit. Make it as early as possible in the life cycle of the items in the workplace. One can do redesign of the process, one can retrofit the existing workplaces, the facilities, the equipments, tools and plants and machinery and the whole working scheme, so that you can bring down or control the risk as early as possible in the design stage itself. Enhance the work environment by including better prevention methods in all the design processes. Certainly include feedback from the workers and information about the near miss events in the redesigning the process of your plant. Carry out FMEA and FMECA to thoroughly look into the risk mitigation and loss prevention methods which were discussed in few lectures earlier. Kindly list out the hazards to the workers and redesign the process to mitigate or to minimize these hazards. Focus should be essentially on selection of equipments, process methods, tools, etc. Initiate design schemes that can eliminate hazards in the fundamental stage itself. FMEA is one interesting study which can help you to do this. Dear friends, cultivate work culture of minimizing hazards in your plant area. Safety should not remain simply as an objective, it should become way of life in the plant. Once we said this, let us quickly see why safety norms are always challenged in deep water oil explorations. That is, what are the HSE issues in deep waters? Protection from hydrocarbon gases and safe inventory of gases is one of the main and critical issue when you talk about deep water oil exploration and production. Reducing noise level of platforms, which can cause fatigue to the operators on board, should also be very interesting idea, so that the noise level of the platform should be brought down within an acceptable standard levels. You must know how the design can adapt to the extreme weather conditions, or you must have schemes which can mitigate the extreme weather conditions on your plant. You should educate players participate in HSE, which goes beyond life and assets, but also environmental protection should be a basic policy. Increasing awareness among players that HSE leads to sustainable business is a very important objective which can promote safety culture in the entire production unit. Having said this, we started moving our lectures from risk towards hazard management. Let us quickly see the comparison between hazard and a risk. Hazard is a scenario where risk is the realization of the scenario. Hazard is a situation resulting in more likelihood of an incident, whereas when the incident becomes an accident, this is called risk. Hazard identification and risk assessment combined together is called hazard evaluation. Risk assessment is also a part of hazard analysis, which we did in few lectures. Now, to summarize the lectures in first module, I have got certain exercise problems which I will try to solve now for you. I have also given certain self assignment problems for you to answer, so that you try to answer them and let me know the difficulties. Let us quickly see problem number 1. A statement is reproduced from the e-news of an accident report. Please read the statement carefully. A contractor accidentally cut a 250 millimeter propane line operating at a very high pressure at a gas refilling station. A large vapor cloud estimated to cover an area of 45 acres was ignited about 4 to 5 minutes later by an unknown source. So, these two events occurred parallelly. Liquid products from 5 of the 26 cabins fed the fire with an estimated 600,000 barrels of LPG for almost 6 hours before being controlled. Both the engine driven firefighting pumps failed, one because of intense radiated heat which damaged its ignition wires, and the other failed due to explosion broke of side glass fuel gauge, which resulted in spilling of diesel fuel that ignited and destroyed the fire pump's engine completely. This is a very interesting accident statement which is reproduced from a news report. Now, the questions are the following. Based on the above statement, answer the following questions. Identify the initiation, the propagation and termination steps for the above illustrated accident. The second question is how an integrity safety can help to prevent and contain this accident. Of course, I will solve this and give you the answer in the next slide. Initiation may be essentially from the activity carried out by the contractor, whereas contractor started cutting the 250 mm pipeline. Propagation initiated from an unknown source that ignited the vapor cloud. So, be careful about the inventory or the stock of inventory which are hazardous chemicals near your plant. The second source of propagation can be the large inventory of LPG gas itself, which fed the fire for about 6 hours. Now, the question is how this can be terminated. Termination must have come from the fire pumps, the engine driven fire pumps that control the fire finally, but of course, they also get damaged in the process of firefighting. Please note that this cannot be taken as an initiation of propagation, because it is the failure of the firefighting system and not the event that is being discussed. The second question is about how one can improvise inherent safety to control the spread of such accidents. Inherent safety relies on chemistry and physics to prevent such accidents instead of relying on the control systems and operating procedures to prevent such accidents. Following inherent safety measures would have controlled the above accident very carefully. Huge inventory of LPG cylinders in the site would have been avoided. Intensity would have been minimized by reducing the inventory of LPG cylinders. Alternate pipeline could have been used. This could have reduced the pressure in the existing pipeline, which was ultimately cut by the contractor even after a proper work permit was issued to the fellow. Therefore, alternate pipeline would have been substituted to carry the high pressure CNG gas. The second question is on risk assessment. Let us read this question carefully. It is a very interesting question which most of HSE executives need to answer. An employee works in a process industry with fatality accident rate of value 4. This industry has normal working hours. As the employee gained experience in this trade, he wishes to change his job. Another oil and gas company in abroad offered him a job. The work agreement of the new company states that his man hours shall be only 4 hours per shift and have to work only 200 days in a year. For your reference, table 1 shows the fatality accident rate for different industries, which I will show you subsequently. The employee is confused after looking at this table because he foresees a higher risk rate in oil and gas industry compared to the process industry where he is presently employed. Now he approaches you as you are the HSE consultant and set the following questions to him. Should the employee opt for the change in his job? Being HSE consultant, should you advise him to do so? Please explain the basis on which you will work out his safety in the new job, because he has shown his concern because the new job oil and gas industry has got a very high FIR compared to the present industry where he is working. The second question is more interesting. Suppose the employee wants to shift back to his original employer after his abroad assignment is over. Should you advise him to bargain towards working hours so that he faces the same fatality rate as that of his recent abroad assignment? If so, state briefly those lines of advice what you will give him to take the next job. The table 1 shows here is the fatality accident rate for various industries. If you look at this table carefully, the industry what the present person is working is a process industry whose FIR is closely around 2, whereas the one which is want to shift is an FIR with 62. So the fatality accident rate of a very high number bothers the person to decide whether should he shift from the present industry to the new industry whose fatality accident rate is phenomenally high. Therefore, he approaches you as a consultant and you should advise him. Let us see the solution for the specific problem question by question. Let us take the first question A. For a process industry, as stated in the example, the working hours are normal, that is 8 hours a shift for 5 days a week for 50 weeks. FIR is actually worked out on an average of 1000 people, that is the standard norms. So 1000 multiplied by 50 weeks of his work and 8 hours a day and 5 days a week for 50 gives him a value of so much. So FIR for 108 man hours is 4, as you see from the table. In the case of an abroad assignment where the person is employed or offered an employment in oil and gas industry, the working hours clearly show so only 4 hours a shift for 200 days. FIR is still sampled for 1000 workers. So 1000 of 50, 4 hours a day of 200 days gives only 40% of the existing risk. So FIR for 0.4 of 108 will be obviously 0.4 of 4, which will be 1.6 in his mind of comparison. This is the FAR for the new job. As the fatality rate is much lower than his present job, he should opt for the new job. One can ask me a question, how this FAR has been reduced? Because the working hours are reduced. Friends, please understand, fatality accident rate is not a simple number. It depends on how many hours you are exposed for that risk. However, referring to table 1, the employer developed a serious concern as the FAR for oil and gas industry is 62. It is essentially due to this FAR the abroad company offered him a job for less number of working hours in a year. In simple terms, jobs with higher FARs generally should reduce the working hours, because by doing so they are limiting the exposure hours of any worker to accident situations. As the FARs go higher and higher, generally working hours per year becomes lower and lower. Now the second question, the person wants to shift from the oil and gas industry back to his principal employer, which is a process industry. Now he wants to maintain the same FAR. The employer's total man hours should be 0.4 of 108, that is what you have seen in the calculation here. Therefore, he shall now bargain to his present employer that only for 800 man hours per year, that is 3.2 hours per day, he will work. This makes the total man hours in the process industry for 10,000 persons as 0.4108. So the person will have the same FAR as he is presently working in the oil and gas industry. I have certain questions for the self assessment. These questions are very important because you must try to answer them based on the knowledge whatever time from the lectures and from the reference material suggested to you in the NPTEL website. Case sheet highlighting the facts of an accident occurred in a process industry in the recent past is given below. As a HSC executive, analyze the problem associated with the subject in terms of risk perspective and propose the following. What are the possible methods of risk analysis as applicable to the case cited? What is the choice of appropriate method, justifying the reasons for the same? Can you do a detailed risk analysis of the problem? Can you draw conclusions as derived from the analysis and not from the case sheet? Also, can you give your recommendations to the local administration in HSC perspective? Let us see what is a case sheet. Case sheet is about a gas tragedy case. The gas tragedy at XXX location was an industrial catastrophe that took place at a pesticide plant owned and operated by XXX Limited on December 3, 1984. Around 12 am, the plant released methyl isocyanate gas and other toxins, resulting in the exposure of about 500,000 people. Estimates vary on the death toll. The official immediate death toll was about 2259, which was confirmed later to the total of 3787 deaths related to the gas release. Other government agencies estimated 15,000 deaths. Others estimated 8,000 to 10,000 died within 72 hours, whereas 25,000 died since the gas related problem diseases has occurred. There are currently civil and criminal cases related to disaster going on in the district court against XXX Limited, with an arrest warrant pending against the CEO of the company. No one has been yet prosecuted so far. Let us quickly see what are the equipment and safety regulations which must have been followed and violated. It emerged recently during the civil action that the chemical plant was not prepared to counteract such problems. No action plan had been established to cope with the incidents of this magnitude. This included not informing local authorities of the quantities or dangers of chemicals used and manufactured. The methyl isocyanate tank alarms was not working for the past 4 hours since the accident occurred. There was only one manual backup system, not the 4-stage system as required in the original design as per the safety norms. The flat tower and the vent gas scrubber had not been in service for 5 months since the accident occurred before the disaster. The gas scrubber therefore did not treat the escaping gases with sodium hydroxide, which is caustic soda, which might have brought the concentration down to a safe level. Even if the scrubber had been working, according to investigation reports, the aftermath of disaster discovered that maximum pressure it could handle was only 1/4 of that which has been present in the accident. Flat tower itself was improperly designed and could hold only 1/4 of the volume of gas that was leaked. To reduce the energy cost, the refrigeration system designed to inhibit the realization of MIC had been left idle. The methyl isocyanate was kept at 20 degrees Celsius, not at 4.5, which was supposed to be as per the safety norms. The steam boiler intended to clean the pipes was out of action for unknown reasons. Slip blind plates that would have prevented water from pipes being cleaned from leaking into MIC tanks through faulty valves were not installed. Their installation had been omitted from the cleaning checklist. Water sprays designed to knock down gas leaks were poorly designed. Set to 13 meter and below, they could not spray high enough to reduce the concentration of the escaping gas in the atmosphere. The methyl isocyanate tank had been malfunctioning for roughly a week. Other tanks had been used for that week rather than repairing the broken one, which was left to the stew. The build-up in temperature and pressure is believed to have happened, which affected the magnitude of the gas release. Carbon steel valves were used at the factory, even though they corrode when exposed to acid, which was a known fact. On the night of the disaster, a leaking carbon steel valve was found, allowing water to enter MIC tanks. The pipe was not repaired because it is believed it would have taken too much time and be too expensive. AXXX Limited admitted in their own investigation report that most of the safety systems were not functioning on the night of December 3, 1984. In November 1984, most of the safety systems were not functioning. Many valves and lines were in poor condition. Tank 610, which contains 42 tons of MIC, much more than safety rules, was allowed in operation. Exposed at high temperature, MIC breaks down to hydrogen cyanide. According to chemical experts, at 200 degrees Celsius, 3% of gas is hydrogen cyanide. However, according to another scientific publication, the methyl isocyanate, when heated in gas phase, starts break down to hydrogen cyanide and other products above only 400 degrees Celsius. Concentrations of higher as 300 ppm, which was exit, can lead to immediate collapse of the whole system. During the nights of 2nd and 3rd December, a large amount of water entered the tank. A runaway reaction started, which accelerated the contaminants, higher temperature and other factors. The reaction generated a major increase in temperature inside the tank, which rose to about 200 degrees Celsius. This forced emergency venting of pressure from MIC holding tank, releasing a large number of toxic gases. The reaction was accelerated by the presence of iron from corroding non-stainless steel pipelines. It is known that workers cleaned pipelines with water. They were not told by the supervisor to add slip blind water isolation plates. Because of this and of the bad maintenance, the workers considered it possible for water to have accidentally entered the methyl isocyanate tank. If you look at the timeline of the summary, at the plant at 21 hours water cleaning of pipes started, 22 hours water enters the tank, 23:30 emitted from the vent gas scrubber tower. At midnight the larger siren sounds and turned off. At midnight again the siren is heard within the plant area. The workers escaped. In the outside at 23:30 first sensation due to gases were felt with the public. It caused suffocation, cough, burning eyes and vomiting. At 1 o'clock in the midnight, police were alerted, residents of the cover area evacuated. AXXX director denies any leak in an official press release. At 2 o'clock in the early morning, the first people reached the hospital. Symptoms include visual impairment, blindness, respiratory difficulties, frothing at the mouth and vomiting. At 2:10, the alarm is heard outside the plant. At 4 o'clock, gases brought under control. At 6 o'clock, a police spokesman said in the loudspeaker everything is normal. Let us look at next question for self assessment. A company is contemplating changes to the process in order to reduce hazard in a given process system. Company has the following data about the change. If there is an accident, there will be multiple fatalities and the damage will be more than Indian rupee of 25 crores. The hazard event occurs once per year and there is a very remote chance of the accident sequence to follow till completion. The cost of correction of hazard in terms of additional safety results is about Indian rupee 3 crores. Use William Fine method and determine the following: risk score and recommended action to correct the hazard, cost justification and a decision to supplement the change in the process. Question number 3, a substance has got TLV TWA, time weighted average of about 200 parts per million. A TLV STEL, that is short term exposure limit, of 250 ppm and a TLVC of 300 ppm. These are the characteristics in terms of parts per million of specific substance or a chemical. Now, the data in the following table is taken in a work area. A worker on an 8-hour shift is exposed to this toxic vapor. Now, the question is the exposure within compliance limits? If not, what are the violations? Assume that the worker is at lunch between 12 to 13 hours and is not exposed to these chemicals during that time. Now, one may require a table of how the exposure is attacking the working personnel in an 8-hour shift. So, the table gives you the detail. Starting at 8 o'clock in the morning till 5 o'clock in the evening, leaving the lunch hours, that is between 13 and 14, the data has been taken in terms of concentration of ppm what the person is exposed. With this data, kindly answer those two questions which I asked you in the last slide. Example question 4 for self assessment. There are two totally independent systems, naming A and B, exist in a plant which can lead to potentially dangerous events in a given process. Now, the question asked is, if these systems operate simultaneously, the effect could be even more than dangerous. There is a probability of joint occurrence of two such events and also their average duration of such joint occurrence. Two relief valves discharge in the same header in the process line. I will show you a figure in the next slide. The header is undersized and could burst if both valves discharge simultaneously. It is estimated that the frequency of occurrence of event A is 5 per year with a duration of 45 minutes each time, and that of B is 1 per year with a duration of 30 minutes each time. Estimate the frequency of rupture of the header and duration of discharge for the ruptured header. These are the two events, A and B valves, which are operating on the common header, which will lead to the blow down drum and the flash stack. The question is posted in the previous slide. Please understand the question and give me the answers for both the questions asked in the slide. The next example is very interesting. 5 departments in an oil and gas industry are demanding for financial assistance to improve the safety of the existing system. The organization uses logical process of risk analysis as a guideline for allocating funds with the goal to reduce the potential loss. Data for the analysis required is given below in the next slide. Please identify the priority of the departments to receive funds. Use table 1 given in the next slide for the problem. The table 1 shows there are about 5 departments in a given unit. Their hazard scores, control score are given. The property value in terms of lakhs and business interception cost in terms of lakhs are given. The composite data in terms of personnel value and exposure in lakhs are available to you. Kindly do the risk ranking and then try to advise as an executive which department amongst these 5 would receive the maximum funding in terms of risk mitigation and solution for the existing risk problems. Next question is as follows: state the differences between the what if analysis and the decision chart that is used in Morgan's risk analysis. The next question is very interesting. There is a figure of a pilot operated relief valve, which I will show you in the next slide, which is commonly used in the main high pressure installation, which is shown. The main valve is operated by a small pilot valve mounted above the main valve body and is connected to the main valve by an external supply and the exhaust tubes. The pilot valve controls pressure on the piston that holds the main valve with the seat. This type of valve reduces load on the spring that is needed to hold the valve closed and therefore result in more rapid reseating after use. The items for failure mode and effective analysis are identified as follows: the seat, which is indicated as 3 number in the figure, the piston seal and liner indicated as number 7 in the figure, the shipping spring as number 8, the pilot valve as indicated as number 11. The numbers given in the bracket indicate the component number in the figure, which is now shown to you. Assume the severity and frequency rating appropriately on a scale of 10 point and perform a detailed FMEA for the pilot relief valve shown in the figure now. You can see here the component 1 is the entire body of the valve, the component 2 is the nozzle, the component 3 is the seal, the component 6 is the piston, which is being shown in the valve here, component 8 is the shipping spring, which is actually used to activate the recentering of the valve for the closure, and 14 point is the dipper valve, which controls the pressure on the internal line. Try to understand the mechanical working of this valve with the help of the slide shown in the previous one and prepare a detailed FMEA for this particular problem. The next question is interestingly a case sheet where you have got to prepare the hazard and operability study on LPG bottling plant located in India at location YYY. The LPG bottling plant is operated by an XXX company, which has got an LPG bulk storage capacity of about 900 metric ton. It is being stored in 6 bullets of capacity each of 150 metric ton. The bottling plant is under operation to refill this bulk stored LPG into cylinders, both for domestic and commercial use. The main operation of the plant can be categorized as unloading of LPG from trucks to the storage bullets, supplying LPG from the storage bullets to the bottling plants. The third area can be refilling of cylinders. Prepare an ASAP report for the said case study. Visit the nearest LPG bottling plant by your area to understand the working model of this plant. The next question is on preparation of FMEA report for a brake system assembly import in a passenger car, which I will show you a video at the end of this lecture, following by which another question is on ASAP report for a flow diagram, which I will also show you as a video now. Watch this video. This video has got 2 valves of a passenger car, which will be used to control the speed of the car in case of any unforeseen emergency. 2 valves will have sensors S1, S2 connect to the microcomputer. They should open or close the valve as they are required. Sometimes the microcomputer may not receive the signal properly. There can be a lapse of communication between the sensors to the top of the valves, and in that case sensor S3 will operate the brake system effectively. So, you have to do an FMEA for this kind of brake assembly system in a mechanical device in a passenger car system, identify the components and try to find out the ranking of criticality of these components in terms of effective working of the passenger car. The figure what you see here is combination of 3 tankers, tanker T1, tanker T2 which is a supply line, and tanker T3. There is a pressure relief valve located in tanker T1, and of course there is a process happening in tanker T3. The tanker T3 receives chemical from T1 and T2 which is passed through a mixture and the strainer respectively. Now in case if the chemical from the tanker T1 passes through the strainer which is pumped out, and a pressure gauge is maintained here to see the pressure, if there is any block in the line because of the strainer, because the tanker T1 may receive chemicals with floated and suspended particles. If the strainer blocks them, then in that case this area of the supply pipeline becomes empty, which results in failure of the pump P1. Therefore, no chemical from tank T1 will be now pumped to tank T3. However, chemical from tank T2 alone comes to tank T3. A very simple process which makes us to understand how to write down a HAZOP report for this kind of study. So, prepare an HAZOP report for this, identifying the segment and see what are the design intents and the deviations of the given problem. Ladies and gentlemen, this was the summary lecture of module 1, safety assurance in HSC management, NPTEL IIT Madras. I have given you certain questions for answering. You can answer them. Any doubts related to this can be please posted to NPTEL IIT Madras. Thank you very much and bye.